All right, everybody, hear me okay? Cool. All right, so my name's Jarret. Raim. Rack and I are both Matt and I work at Rackspace, and I came up through the dev world. I was a security consultant for a lot of years, and at Rackspace I was been working on the SDLC process, and now I actually build security products for Rackspace. So those products that you would use as customers to secure your infrastructure.
And I'm Matt Tesauro. I wear kind of two hats, I guess. I have an OWASP hat where I'm quite active and busy in OWASP. The Live CD and WT are probably the more publicly known projects of mine. And I'm also a Racker with Jarret. And I work for the Product Security Group, which is the group charged with the SDLC operations around all of the product that we end up launching. So our cloud sites, our cloud servers, all that. We keep an eye on that and keep up with the releases, work with the devs, and try to make sure that the product we ship is as secure as possible.
So Matt and I have been talking about doing a presentation like this for a couple of months now, and it kind of stems from our experiences at Rackspace where as an organization that's kind of rapidly moving towards CI/CD, so continuous integration, continuous delivery, some teams that are there, some teams that aren't, dealing with 15-year-old legacy software and those types of things, we've started to feel like there have been holes in our approach and problems that the typical kind of approaches that we've dealt with in other companies as consultants haven't really been able to fill. So we've been talking for a long time now about kind of what we want to do going forward and what we think the future looks like. And it's actually been really heartening to see a lot of the rugged track yesterday that's kind of talking about a lot of the same stuff that we've been talking about. And so we want to talk a little bit about kind of what we've been feeling and why, and try to back up with some numbers, where we are and then where we kind of want to go. So we kind of start out with the idea of, we've been feeling like we're not doing a great job, right? There's more that we should be doing for a lot of our products, right? That there are some cases where we just kind of have to throw up our hands and hope for the best, which is not really a good place to be in, right? So if you kind of look at the state of software security that we have now, right, the numbers aren't great. So from the Sensic vulnerability report, you can see over time, we have some fluctuations in the individual vulnerabilities, but a lot of them are basically staying the same. Year over year, they don't really go up, they don't really go down, even though we're writing a lot more software. Right, and the amount of money that we're spending on this type of stuff is pretty excessive. And the really disheartening thing is some of the older vulnerabilities that we've known about for a really long time, like cross-site scripting and SQL injection, are not getting any better, right? And so if you look at the open source vulnerability database, you kind of see the same story, right? You might see some kind of variation in the types of vulnerabilities, but really the number is staying pretty constant, right? And even if you look at this, you kind of see, well, maybe there's a little downward trend, like maybe there's a little hope. But if you bring up the HP cybersecurity report, which is attacks that they've seen from their IDS IPS installations, the numbers are actually going up significantly, right? And even scarier, if you look at the difference between 2010 and 2011, the overall increase is relatively low, but if you split out just the web vulnerabilities, the increase is much higher, right? So out of the increase in vulnerabilities that we're seeing, most of them are being on the web platform, which kind of matches, I think, our feeling and probably a lot of our kind of experience. If we look at the general, so Veracode, for people who haven't used it before, is a binary analysis kind of engine. And at the end of a particular scan, they assign a score, right? They kind of roll up all your vulnerabilities and tell you kind of how good you're doing as an application. And the fact is that over the last couple of years, it's stayed pretty much flat. Things aren't getting any better, things aren't getting any worse, which is, not particularly great when you're spending a lot of time, energy, and money trying to make it better, right? So kind of what we came up with is that what we're doing is not working well enough. We need to kind of take a different tack, figure out something else that we can try because what we're doing right now isn't working, right? So the traditional kind of scanning and signature schemes are great in certain scenarios, right? If you have legacy Java applications, .NET applications, various other things, where the scanners can really do a good job of looking through your app and modeling it, then you can get a lot of value out of that, right? So, running Fortify on an ASP.NET 2 application or a classic ASP application will get you a lot of value for the dollar, right? Unfortunately, the cases in which we can use those tools to their fullest are really declining rapidly, especially at Rackspace, right? So we build mostly REST APIs in Python, right? Almost all of OpenStack, which underpins our entire public cloud, is built in that manner, right? So when you look at what tools I can use, I can't use static analysis because nobody's really doing static analysis for Python. I can't use dynamic analysis because nobody's really doing dynamic analysis for REST APIs, just web stuff. WAF doesn't buy me anything because it's aimed at HTML, right? So all of a sudden, you kind of the typical things that you might pull out of your bag to kind of get control over a situation now is no longer functional, right?
And one other thing to mention too, with the continuous delivery, continuous deployment, what have you, you don't have a scanning window, right? If you're pushing code multiple times a day, you don't even have a window big enough to run a scanner if you had a scanner that would work for you anyway.
Right, at least not before you push production, right? You can always scan production. So a lot of vulnerability classes, even under these tool sets, don't have great answers, right? When you start talking about things like direct object reference and some of the other kind of logical vulnerabilities, scanners don't help you there, right? So even if you had a scanner that was really effective against your code base, there's still a whole class of attacks that you're not kind of looking over, right? And then, as I mentioned, like the new technologies are really not making anything better, right? When I'm pushing 30 times a day, when I'm switching languages, when I have a lot of polyglot languages, right? At Rackspace, we run pretty much every language you've ever heard of, and so that becomes much more difficult on an information security crew because I can't be an expert in every language, right? It just takes too much time. And so we've been kind of trying to figure out what we can do about this.
All right, so the other thing that's traditional, oh, I get to figure this thing out. Hey, look, it works. Hey, the other thing that's very traditional in this is just the mantra, and this is just what security people say, is like defense in depth, right? It's gospel. We don't question that. But if you really start thinking about it, right, we talk about defense in depth. You have firewall, you have AV, you have intrusion detection, you have all these layers, and we think of it like the layers of an onion, God help us, walls of a castle, right? All these trite things. And yes, you can take me out of the security clue club because I just said walls of a castle, right? But we have all these things, and this is like, it is ingrained in the security space that this is what you have to do. But when you really think about it, if I have a RESTful API over SSL, the firewall buys me nothing. IPS IDS buys me nothing, right? Because I'm going from the client to my API in an SSL tunnel that's terminating at the API node, right? And the firewall's obviously open. That's not defense in depth. What you really have is defense in breadth, right? We have controls to handle areas of security issues, but they're not truly overlapping like an onion, right? The WAF is great for known application attacks. The network is handled with the firewall. The endpoint can have, for malware, it has AV, right? And for physical access, you have the card readers and all that good stuff. But that's not defense in depth. That's defense in breadth. And I think it really changes the way you think about things if you realize, wait a minute, this really isn't. That firewall buys my API or my web app nothing. IPS IDS buys my web app nothing, because 443 is open and it's encrypted to the endpoint.
Right, and we all know as people who have worked both in the industry and as vendors, right, that the spend in these different areas is really quite disproportionate, right, especially to the attack platform. So if we're looking at web application attacks being the #1 kind of growing area that we're seeing attacks, yet businesses are still spending 60, 70, 80% of their money on firewalls, something has gone awry, right? Especially when, even so when you talk about these things being defense in depth, it's like, oh, well, I'm buying a firewall, that's buying me some value. It's like, yeah, it is, but it's not buying you any value against web application attacks where we're not necessarily spending enough of our kind of resources, right? So it's not all doom and gloom, right? So we have done a good job. There have been successes, right? So, part of our kind of goal was, all right, so we got this feeling that we could be doing a better job, right? So let's go look at the places where we are doing a better job and try to figure out why they were successful versus the places that aren't as successful, right? And then maybe we can learn something from that, right? So if we look at SQL injection, right? The trend is down, not a lot, right? But the trend is down, so it's, it's going down. And I think one of the things that really kind of tipped this for us is, as a consultant, I saw tons of SQL injection, just tons of it, right? All over the place. Every app that I touched almost always had SQL injection, right? At Rackspace, I don't see it ever, right? And the reason being that every single piece of software that we write uses an ORM, right? ORM's not bulletproof. There are obviously ways you can get around it. It's not 100%, right? But for the most part, it's going to eliminate the vast majority of SQL injection, right? So as a vulnerability that I spend my time looking at, I don't really look that hard for SQL injection at Rack, right? Just because that happens to be our technology stack, right? So some other general success stories, and if you've listened to Michael Howard, I think a lot of these will be familiar to you, right? So, when we talk about buffer overflow attacks and those types of low-level things, when you move to managed languages, this type of attack goes away, right? When you look at, DEP and ASLR, obviously not 100%. There are still techniques to get around those tools, but it certainly has made writing malware a much more difficult process, right? And so it increases the cost to various other people to be able to do these types of attacks. We've seen a lot of value out of sandboxing and UAC type scenarios, right? So Chrome sandboxing off Flash, and then you can see that the Flash vulnerabilities that are out there are not buying you anything. Now, again, not 100%. I think in Pwn to Own, that's how they got hit, was through the Flash sandbox, right? But it is effective at kind of preventing some of these types of attacks. Banned APIs are another one that we've seen a lot of value at, and this is one where you can pull a lot of really great numbers from Microsoft. where they look and they say, okay, well, we had to issue 7 critical security patches to customers over a 3-year period that all boiled down to people using memcopy wrong, right? So we're going to come up with a replacement that makes it so you can't do that, and then we're going to ban memcopy, and then all of a sudden all that stuff goes away, right? And so that's been super effective for them, right? That's not appropriate for everybody, right? But for Microsoft, that's been very effective.
Well, and one other thing about banned APIs, right? You've just made the problem space of checking for those things greppable, right? Which is huge.
Right. And so lastly, as I mentioned, SQL injection is one of those things that if a customer is using an ORM or is using a framework that really includes one, then it's much less likely for me to find it, right? So if I'm looking at 2 applications and one's written in .NET and one's written in Rails 3, right? What I look for is very different. I don't spend a lot of time looking for SQL injection in Rails because assuming that they're using kind of the basic set for Rails, it's probably not going to be there, right? ASP.NET's all over the map. Right? They could just be using straight SQL. They could be using link to SQL or entity framework or whatever. So it might be there. It may not be there, right? And then just kind of some numbers off of the Microsoft SDL, right? So Windows Vista is what Windows Vista was. But at the end of the day, Vista was about 3 to 4 times the size of XP for code base size, right? So you're talking about vulnerability density, right? Assuming vulnerability density was the same, Vista should have had 3 to 4 times the vulnerabilities that XP did. Right, and it just didn't, right? And the numbers bear that out. In fact, it's significantly less, right? So now, Vista had its own problems, and the SDL is not perfect, but it's hard to argue with those kind of results, right? They're getting back what they expect. Now, we all know that vulnerability counts are, not the be-all, end-all way to talk about security, but unfortunately, it's kind of the thing we have. And so it's useful that Microsoft spent all this time and invested a lot of time and energy and money doing things like banned APIs and various other things, and they at least have some proof that they think kind of shows that's being effective, right? So what do these successes have in common? What do we learn from this, right? Well, the thing that we took away from it was that what they really do is change the behavior of the existing system to make it harder and impossible for developers to make the mistake in the first place, right? Devs don't use ORMs because they're secure. They use them because they solve their own problem. We just get the side bonus of all of a sudden SQL injection pretty much goes away, right?
So another place where there's been actually pretty good improvement here, and you've heard this more than once at this conference, is DevOps, right? With development cycle time is decreasing, right, and you have faster and faster pushes to production. The continuous integration, is it late on Friday? Yes, it is. Continuous deployment, right? Those scanning windows, like I mentioned earlier, those are out the door. And then particularly at Rackspace, right, the scale of the number of machines is ridiculous. I mean, it's just ridiculous and then times 2. So in this environment, you're like, how do you make DevOps better, right? How do you make this work, right? Well, and actually, from a security point of view, right, if you want to be successful, you can't prevent systems from going to production. You cannot be the stop, right? You have to figure out how you can be as fast as the developers in terms of making these things work, right? Rackspace is not going to stop a major, well, assuming some fundamental flaw isn't there, we're not going to stop a product launch for a minor vulnerability. We need to, I mean, I'm sorry, this is how we make money, right? We sell product and that's how we make money. And you're not going to tell the business, stop making money, I'm scared, right? That's just, it's not a winning argument.
Right. And in the CI/CD world, right, it's no longer okay for us as software to security to go to a team and say, hey, you know what, before you push to production, you have to give us 3 days to run our scans or do whatever it is, right? Well, these guys have spent all their time automating their entire process from beginning to end so they can go from check-in to production in 15 minutes. And if you're the team that comes in and goes, yeah, no, now you gotta wait 2 days, right, that's never going to happen, right? So it's not even that we know that there's vulnerabilities and we have to decide whether or not to go to production. I mean, that's always gonna be the case, right? But we we don't even have a chance to look for them, right? And so for us to be successful, we can't be separate from the development teams. What we do has to fit into the pipeline that they've built, or it's just not gonna get done.
Right. And at the very least, you have to have at least enough coverage for whatever compliance regime you're under, right? And I've already said that you have to be as capable and quick as the development teams. And by the way, this isn't unique to Rack. A friend of mine, not me, happened to see a Gantt chart of a project plan, right? And you're walking down the list of so many days, so many days, so many days. Security testing, 0 days, right? You have planned to fail right there. And I still have I took a picture of that Gantt chart because it was just priceless, right? I mean, wow, this is awesome. We've planned to not do security testing. What could go wrong? So Jarret and I have been kicking around this idea of test-driven security, and this is not unlike a lot of the other DevOps-y concepts. And this is not new rocket science. But the idea here is you need to do this quick iterative cycle. So you identify a security weakness. And a great example is Jenkins a while back, a couple weeks ago, had a pretty ugly vulnerability unauthenticated issue, right? We found out about that, and we have Jenkins. So first thing you do is you quickly look at what that vulnerability looks like and give it a score. Like, how scary is it? Like, how much risk does it pose to Rackspace, right? You write a test to go find that. Where are the Jenkins boxes, right? And this has to be automated. You can't go out to the gazillion boxes we have and ask them one by one, are you Jenkins, right? And you're not going to do a vulnerability scan of a jillion boxes to find out which one might be Jenkins, right? Then you watch the test fail, right? After you've written this test and you can identify Jenkins and pull the version number, they're going to fail, right? Because this is just released patch. You implement a fix, and then you watch all those tests slowly turn green. And now you have situational awareness around where you are in terms of state of patching. And if you can get to this cycle, it's an amazing thing.
Right. I mean, so if you're a developer, right, this should seem very, very, very like normal, right? This is how test-driven development has been done for years and years and years and years, right? And so, you know, to a development, you know, a developer, this is a very normal way to do things, but it's not something we've really done in security in the past, right? And one of the nice side effects that we get out of this approach is kind of two things. One is kind of a multiplication of effort that we can get out of our security teams, right? At the end of the day, if I've got 8 security guys and I've got 5,000 developers or whatever your number is, right, the coverage is just not enough, right? I can't look over the code all the time. I can't even scan those individual applications on a reasonable basis. Just can't do it. Don't have enough people, right? But if I can go in and write a test that automatically applies to 5,000 machines or to, you know, all the different code that's being written at Rackspace, then it's now worth my effort to write that test, right? I can get more out of my developer time, right? So when, you know, InfoSec people are hard to find and they're expensive, right? So having them be glorified scan monkeys is a waste of your time, right? And it's the waste of their time. And so by having them build up this suite of tests over time, it's the same value that you get out of unit testing and development, right? Writing one unit test is not super useful, but over 5 years, you build up a suite that becomes very useful, right? And so investing that time at the beginning to build the framework and get there means that you can do more with fewer people, right? In addition to that, the second thing that we get out of this flow is that because this is all automated, we can metricize the bejesus out of it. Right? So all of a sudden I can start answering all of the questions that matter, both from a compliance standpoint and just from a justifying our existence standpoint, right? How many outlying vulnerabilities do I have? How many machines are vulnerable to particular types or classes of vulnerabilities? What's my average time to go from unpatched to patch to, you know, to 50%, to 75%, to 95%, to 100%, right? How long is it taking me to go from security weakness identified to writing a new test, right? All these different types of things that then tell me where I need to invest, how much money I'm spending in particular areas. And all this can be done kind of with open source tools, right? You don't have to go to IBM and spend $18 bajillion to do that. You can if you want to, of course. But you know,
IBM prefers that.
Yes. But these are things that can be done right away, right? Because development groups have already built all of the tooling that we need. We just need to step into it as security people and use it.
So really one of the key things here is you want to define the end state that you want, not scan to see how things really are. Right? This is sort of an inversion of how you think of things, right? The traditional VA mentality is like, I have no idea what's going on in there in the big scary data center, so I'm going to run Nessus or a scanner of your choice, and I'm going to find out how good or bad we are, right? That's kind of back-asswards, quite honestly, right? What you really want to do is define what you want the state to be, write a test to see if you're in that state, and then run it continually, right? That's really the way to go, because then you can, as quick as you're running that test, you can know where you are second to second, moment to moment, however quickly you can run that test.
Right, and it's worth noting that this doesn't replace vulnerability analysis, right? So,
no.
You know, it's all perfectly good to say, I'm going to write a bunch of tests that say, oh yeah, I'm going to check my SSHD config and make sure that nobody's allowed to log in as root, right? And that's a great test, and you should totally do that. It doesn't mean you shouldn't run Nessus against your box. You know, and so really we think of a lot of the stuff as we've been doing is more of things that we can put into the development process to give us kind of real-time analytics as what's happening as code is rolling out to production, and we can follow that in addition to all of the stuff that we're still going to do, right? And so about, you know, just doing regular scanning and some of the other types of things that we, you know, that we like, because in certain scenarios those things are very, very effective, and we don't want to give that up.
Yeah, no, not at all, because the other thing you get from this, if you can write tests for a lot of those simple use cases, then the scanners aren't noisy for the stupid things, right? The scanners are noisy for the important things, right? bad, like weak SSL cipher, you can write a test for that. It takes no time. Pick your language. If you can run that across your environment and know you don't have that problem, guess what? Nessus, Qualys, whoever is not going to report that, right? And now you've wheedled down, when you do get a chance to run that scanner, the results you have to deal with. So one of the things we've been looking at is cloud passage, and it is this idea of putting an agent on your computer or your server, right? And you can write rules to say, this is the state I believe the server should be in. So here's just a little example rule of saying, I want this particular ACL for my cron directory. And it'll run on a timed increment and report back up to the mothership, yes or no, right? Yes, if the ACL is correct, no, it's not. Right, so you take that and you run it. And now I know I've got these couple of boxes that are not matching this rule. They're failing the test, right? So, and this ideally is not really what it looks like, but this would be what your dashboard is, right? This is conceptually your dashboard. So you have this big board, and you've got a couple red dots. And now you've just taken the problem space of, I want my cron to be kind of tightened down to just a few servers out of your big wad of servers. And then for each server, we have metadata associated with it, and we can now know that I got to go bug Jarret because he didn't get his server set up right? Even better. And actually, well, I'm jumping the gun. I'll get that to a minute. But so this way, you can actually run. Oh, I thought we had another animation. You can talk to your devs, get them to fix them, run the test again, and watch the reds turn green. Right? This is not unlike normal TDD. Right? Keep running the test until it's all green.
Right. And so we've been kind of looking at Cloud Passage, which is a vendor. Matt and I are talking a lot about kind of building, so we've already got some open source agent work kind of going on that we're going to work on to kind of make this a little bit easier to do, and something that you don't necessarily have to pay for. But there's value in kind of being able to do these types of things. So a quick example, right? I've been dealing with PCI for like the last month, which is why I've been drinking more. But so one of the things I have to do is PCI. I say, okay, well, you need to harden your boxes. Great rule, right? But PCI won't accept anything unless I'm hardening to a standard. It's like, okay, well, at Rackspace, we have people who have been hosting stuff for 15 or 20 years now. We employ the Apache release manager. Yeah, I'm pretty sure we know how to harden Apache, right? This is what we do for a living. But that's not a standard, right? And so rather than me, typing up some, 50-page PDF that I have to send to all of my operations teams and have them go check everything, I write a set of rules, right? And I roll them out across the infrastructure, and I can tell you which machines aren't patched, right? Which machines aren't configured correctly. And I can go and talk to those particular operations teams and deal with it, rather than having to pass blanket policies across the entire organization, which is typically what you have to do when you're in the compliance related areas. It doesn't mean that you don't have the policy. You still have to write the policy because they're going to want to look at it, right? But it means that my ops people don't have to ever read it, right? Which is much more important to me, right? So if I can give them a list of, these are the 5 things that are wrong, these are the reasons why they're wrong, this is what you have to do to fix them, I don't get pushback on that. Right? If I give them a 100-page policy document and say, make sure your servers do this, and every quarter I'm going to come and look at them and tell you all the things that you did wrong, they're not wild about that. Right? And so this makes it a lot easier for me to push these things. And as you start to roll out this infrastructure, all of a sudden your ops people will come to you to start checking stuff. Right? They're like, well, we really want to make sure that it's set like this, because if we don't do this, then it exhausts memory and things break. So can you check for that and make sure we don't miss things or something like that? Which starts to get really useful when your ops people are actually coming to you to use your security tooling. And part of the reason why we like this approach is that initially, so we really like kind of Puppet and Chef, and we'll talk about them in a sec, but not every team at Rackspace is that far. We have a lot of teams, especially a lot of the open cloud teams, that everything's being done with Puppet and Chef, everything's automated, everything, great configuration management, that's awesome. We also have systems that have been around for 5, 6, 7 years in various cases in which they're not all the way there yet, right? And the nice thing about this agent approach is all we had to do is go to all the teams and say, run apt-get install this, and that's it. That's all they had to do. We don't use these agents to make changes on the boxes, right? We use these agents to tell us where the changes need to be made, right? And then we go to the teams and help them make them. And we don't send them like individual notifications. It's usually like, okay, well, we're seeing, this is a small percentage of boxes. We'll deal with those individually. But if we have a lot of them, maybe it's a longer thing. Maybe we need to do training, right? Once you start having this data, you have trending data that you can work with, right? And these types of things can roll into developing Puppet scripts and that type of stuff to make sure you kind of mitigate these problems.
Absolutely. Another thing that you probably may have seen the talk James Wickett did in this room, actually, yesterday, was Gauntlet, right? And he's looking at Gauntlet and using Gauntlet to do some testing. I got very interested in Gauntlet, quite honestly, because, like we talked earlier, we have lots of RESTful APIs, and there's nothing really to scan them, i.e., I've been doing them manually. And doing something manually 1 time, maybe 2 times, isn't so bad. but I really don't want to do it manually the 4th and nth time. So what I'm looking at with Gauntlet is an ability for me to write a my manager friendly description of what my test is doing. On the back end, actually just codify all of my manual testing. So I know at the very least our APIs wired into our CI have met this baseline of what I can automate, which is a fantastic thing.
Right. I mean, there's nothing more depressing than sitting down for like 3 or 4 days and spending a lot of time manually testing an API and knowing that in that 3 or 4 days, that API has revved about 100 times. Right? So there is no chance that whatever you're testing is anything like what's in production, because you're always going to be a little bit farther off, right? So if you spend your time writing these tests, then over time you get a lot of value out of the fact that these are being run kind of every time, and hopefully you don't make the same mistakes you made before, right? So, again, we kind of harp on it, but this is really the exact same use case for test-driven development. Right? There's really nothing different here, except that we're just applying it to security.
Absolutely. Like we said, we're going to talk about configuration management. Puppet, Chef, CF Engine, these are things that are fantastic, right, for my inner sysadmin, right? I love these things. I wish I'd had these things, actually, when I was running a lot more Linux boxes. But as a security professional, what you really need to do is spend your time not scanning, but getting with your DevOps guys and looking at their Chef and Puppet scripts. If I can if I can help them write a hardened Chef or Puppet script, all of a sudden, I'm not affecting the one box I scanned. I'm affecting all the boxing, right? All of a sudden, wham, we now have a hardened way. And the next box that gets provisioned, it will also be hardened, right? It's a beautiful, repeatable thing, and it's a place where you can put in a little bit of time up front, and it pays dividends continually. And I'm like, gee, go figure, we roll out boxes a lot, right?
Yeah.
So it's kind of really handy at Rackspace.
Yeah, so I mean, going back to our kind of alcohol-inducing PCI example, like when I need to do a hardening scenario, right, I can write a policy document or I can write a chef script. Which do you think my ops team cares more about? Right? If I come to them and I say, look, I already did the work, right? Here's the base chef script for hardening your stuff. Let's go through the decisions that I made and make sure you guys are okay with them and how they're going to change what you're doing, and then you can just base your Puppet script on mine. You don't have to make any change. I already did it for you, right? And then when we find a vulnerability like, Jenkins is messed up, I go to our internal GitHub repo, I find the chef script that's provisioning Jenkins for everybody, I make one change, and I roll it back out, and over the next hour, I can just watch all those boxes automatically turn green. Right? Nobody had to log into them. Nobody had to go do the work, right? And if I have, 100 Jenkins boxes, which would not surprise me, then
we got close.
Yeah, we have lots. So all of a sudden, I can see those things start to go across. And when you start to get to the scale of servers that we're talking about now, we can't do it by hand. I can't go to the cloud servers team and say, I need you to hand log into every hypervisor and make this change. Not going to happen. Right? Or if it did happen, it would take 3 months, and by then it's a waste of time, right? And so, getting our teams onto Puppet and Chef is incredibly important, both just for their own kind of usage and moving forward for CI/CD, but also from a security standpoint, we can go and make these changes much easier. They roll across the infrastructure much quicker, right? And now it makes a lot of sense for us to spend our time really deeply looking at these Puppet scripts that our ops teams are using, right? If I wanted to log into one box and spend 8 hours really just fine-toothing the configuration of a particular single Linux server, that's great, but if I have 10,000 of them, that's really not going to buy me much, right? I can spend that amount of time on a Puppet script. It makes sense because I know that the value that I put into that for that 8 hours spreads out across all of the boxes that we have rather than just being limited to a single one.
Absolutely. It does, by the way, though, require a mature organization, and we're fortunate being at Rackspace, we've got that. We've got some crazy clueful people there. So this has been somewhat easy for us.
Yeah, I mean, it's starting from nothing and going to CI/CD is not easy, right? So there's been a lot of talk about DevOps and rugged and stuff like that here, and that's all awesome, right? It's really great stuff. They kind of tend to start to where you're already there, right? And so it's a lot harder to take an organization that has large existing infrastructure and migrate things to Puppet, right? Because I guarantee you the first time you do it, you are going to break everything, right? Because guaranteed, out on your servers, there are configuration changes that have been made over years, right? That you have no idea why they were made, you have no idea that they're there, right? So you write the Puppet script like you think it should be there, and all of a sudden nothing works, and you don't know why because the dev that wrote that feature quit 3 years ago, right? So it's not trivial to start from scratch, right? And that's why we kind of went this direction with the agent, in that we could do that for everybody, whether they're Puppet or not. Once they get to kind of configuration management with Puppet and Chef, things get a lot better, but this is a nice way to kind of walk them that direction without being able to just say, well, the whole business needs to go to Puppet first, and then we'll be super awesome for security, because it's going to take you a year or two to get there. right? A lot of times people don't want to screw with old systems because they're going to be, you know, how many times have we heard that story, right? We don't want to make any changes to it. We're going to turn that off, right? 5 years later, the sucker's still running, right? You know, and so that being able to invest that effort, you know, up front for us, and with the agent, we get the ability to say, okay, well, let's split the metrics between teams that are doing things with Puppet and teams that aren't, right? And all of a sudden, like, the vulnerability window for teams that aren't doing Puppet is significantly longer than those that are, right? I can roll a Puppet script change across our infrastructure in an hour. It may take me 2 weeks to get someone to log into all those machines and make a change for something that's not doing.
5 minutes, we got to roll.
Yeah.
Okay, quickly. Under this new regime, the idea of a day in the life of like a person doing this sort of methodology and what we're getting to at Rackspace is really your job as a security professional should be going in and identifying weakness, vulnerabilities, issues with your environment and writing tests for them, right? The minute you can do that, then you can have the opportunity to get visibility across where you really are, not just like, I think this is bad. I can say this is bad in N percentage of our boxes, right? Take that, combine it with the hardening of Chef and Puppet scripts, and now you've got a very dynamic and monitored environment that lets you know truly your state of affairs, right? Because I've been in other environments where I knew the state of affairs right after I ran Nessus, right? But until the next month when I ran it again, we really didn't know, right? This is a beautiful thing. And the other idea is to review results. Like the nice thing with this, right? If you do a lot of this automation, now I as a security professional can spend my time digging into the deep, interesting problems, right? I can actually review the results of these and see a trend and then go dig down into, like actually Michael Howard was talking today, you can get ideas of like, wait a minute, this is the 4th time I've had this same kind of issue. What's really going on here? Take the time to dig down and find out what it is and fix it globally, right? It's a much better thing.
All right, so that seems to help with OS security, right? That does a good job for making sure that your boxes are configured correctly, right? And so the second side of that is, well, how do we apply this to applications, right? And so really kind of what we came up with is it's the frameworks, right? The places where we've been successful at making changes. You know, Rails has a very specific opinion on how you do development. Now, you can swap it out, right? You don't have to use Active Record, but they say this is how it works, right? You use Active Record. Right, and so am I going to see a lot of SQL injection in Rails? Probably not, because most people aren't using it or aren't doing something that allows us to do that, right? And so, you know, where we've seen that we've been successful is by going in and making changes to those frameworks for developers, right? So the things that we kind of had to live with, right, the bitter pill that we had to swallow, is that developers don't choose tools based on security. It just doesn't happen. Developers don't use ORMs because they're secure. They use ORMs because they solve a problem. Right? And so going in and telling developers, you got to use my special version of Rails or my stupid library that I created because it's more secure doesn't fly. It's just not going to happen, right? Security doesn't drive framework design. We saw this really, really clearly in the Rails community. You know, a security researcher popped up and said, hey, by the way, you have this bug that if you don't, you know, set this special thing on mass assignment, then people can set things they're not supposed to be able to set. And the Rails core community said, well, that's dumb. People just need to be smarter and not do that, right? So then he turned around and hacked GitHub. Right? It's like, well, if GitHub can't do it, then probably everybody else needs to do it. And immediately Rails kind of changed the way that they do things, right? And so when you don't have security people in the core committer groups of these frameworks, you don't get security in the frameworks, right? That's just not their focus. That's not what they're focused on, right? And of course, you know, this is a deep belief at Rackspace, and I think we both share it, is that free as in speech and free as in beer wins every time. Right? If I say, yeah, you can use Rails and that's free and you can pop it open and you've used it before and all the documentation is free and you can go to conferences about it, or you can spend, you know, your company has to spend $250,000 to buy my, you know, hardened version of Rails, it's not going to happen. Right? So,
you got a question in the back.
So if developers aren't asking for secure frameworks, how are we going to get them?
Well,
wait, we'll get there.
I thought we had 1545. Yeah, I got you. Okay. So, to kind of get to your point, you know, security must be part of the frameworks as they gain popularity. It's not something we can wait until everybody's using it and then turn around and try to convince them to change their ways, right? It takes a lot of time to get credibility in these communities where people believe what you're saying. And if you come, you know, if you're Johnny come lately and be like, you guys are doing it wrong, you don't have any idea what you're doing, and here's how authentication should work, you're not going to get real far, right? So security must be championed within the framework design, right? We can't wait. We can't come from the outside and be like, well, I'm a security guy. You devs should listen to what I'm saying, and you should change your code to work this way, right? And we've seen this a lot. People put patches out there and stuff like that, and they're not sensitive to the way that open source gets built, and so their stuff doesn't get included, right? So really what we have to do is find a way to fund this work, right? Because we have to get security people to live in these core committer groups, right? Someone has to be in the core Rails committer group championing security and saying, this is the reason why we should do this. And I've been doing this for 2 years, and I've been committing stuff to Rails for 2 years, so I have the credibility to be able to champion that, right? If you try to come in from the outside, it just doesn't seem to work, right? So to give you a quick example, let's talk about direct object reference, right? Relatively standard vulnerability, it's on the OWASP top 10. It's one of the ones that your application scanners typically don't find, right? So in normal Rails, I have this idea of the various different ways that I can specify active records. So I've got an order in this case, it's got line items, and this order belongs to a user object, right? So this model has no way to determine who has access to this piece of data, right? So if you have a direct object reference vulnerability, someone changes your URL or whatever, pulls an order, they see things they're not supposed to see. Very basic vulnerability. So imagine I changed it to this. I provide an access control header, and I say, hey, you know who owns this? Mr. Framework, who owns this order is this user. That's who owns it. Right? Now I can write some code in the framework that says, every time I load a model, no matter what model it is, I want to check to see if the current user context matches who they told me the owner of this object is. Right? And so if you have a default deny model here where you automatically return false unless a developer provides you something, then all of a sudden direct object reference is a solvable problem. Right? It goes away entirely. And it's something that has to be done. Now, this is a very simplistic example. Obviously, there's more work that would have to be done. You'd have to enable functions and various other things because calculating ownership is not necessarily a super easy thing to do in all cases. But these are the types of things that we could do if you had security people working in the Rails core commit all the time, right? That they have the ability to do that. So last slide here, and then we'll go to questions. So the $64,000 question, and I don't think we know the answer to this. If you know, you should probably start a business because I think you're going to make a lot of money.
Although we do not have $1,000 up for bids. So.
Yes, you cannot get any money.
I got about 5 if you get a really good idea.
So how do we fund developers to work in open source frameworks, right? A lot of us, I think, want to do that. And so is it somebody like Rackspace is supposed to pay? Is it the end user, right? Are they going to pay us to do that? Is it the vendors that are out there? Is it the white hats and the Sigitals of the world that should fund this stuff? I honestly don't know the answer yet. But developing seems to make it work. And I think as security, we need to do the same thing. I just want to give a shout out to some people that are kind of going in the same direction, solving some of the same problems that we talked about. So Gauntlet from Wicket, and Threadfix, which is a way to integrate lots of different security tools, kind of an open source way from Dan Cornell. Useful projects that you should check out if these types of things are interesting.
And one thing that just occurred to me that relates to the how do you get involved and how do you get a security champion in a development group. This is something that I did at Rackspace at a very small scale. This is not like getting into the frameworks, but I sit on a lot of different product teams, right? And go to the regular meetings and their design reviews and yada yada yada. And I'm involved with them. And I'm in one product and I'm hearing how they're going to interact with the second product, and that I know that's not going to work. I mean and quite honestly, this product didn't consider the ramifications of the other product because they just got to get theirs done. So what did I do? I walked over to the other product and said, hey guys, heads up, you might want to talk to them. There's this thing, it looks kind of ugly for you. And I actually got them all to a table and solved the problem, right? And those are the kind of things, not even a security issue. This is a usability issue, right? Absolutely nothing to do with security. But now, both of those product teams know I have their back, right? And now I have way more cred points with them. Where when I do have a security issue, I go up to them and go, remember that last thing? Here's another thing. This time it's security and I need your help. And they'll listen to you if you can provide them value. That's really the key. Like, how am I providing value to the devs?
Yep.
Beyond just telling them, you did stuff bad, it's broke.